Next, we will move on to the summary measures for numerical variables. So we have to first define the numerical column. So let me just write that. Define numerical columns. So again, we will be preparing a list that contains the names of the numerical variables. So let us scroll above and see what were the numerical variables. So you can see age was one of them. Then you have the time spent, number of devices, and monthly OTT bill. So you have 4 numerical variables. So we will just give that as a list over here. So the first one is age. Then you have the time spent. Next is your number of devices. Then monthly OTT bill. Age, time spent, number of devices, and monthly OTT bill. Right? So if you can recall, then for numerical variables, what are the measures of central tendency? These are mean, median, and mode. So we will use these over here now. So first of all, I will calculate, let me just write a comment over here, calculate mean, median, and mode. So here again we will be initiating a for loop numerical columns. So here it will again be going through each item in this list one by one and assign it to this variable call over here for each iteration. For this, then we will extract those from the data frame. Okay, so here we have extracted the values for the current variable that has been chosen, and we have extracted its values from the data frame and saved it in this values. So in order to, first we will calculate the mean. So let us see how we get that mean. So for this purpose we will be using the NumPy library with the mean function. You can also use the statistics library also because it has mean, median. So I just want to show you how NumPy works. So mean is equal to dot mean, and here in the bracket you will write values. So it will call the mean function from the NumPy library to calculate the mean of the values for the column that has been extracted. We can likewise calculate the median also. Again we will call the NumPy library and this function, median function, and we will write values over here. We can also get the mode. So if you remember, for mode we use the statistics function, statistics library, statistics.mode. We are not using NumPy because NumPy does not have a built-in function for mode. So we will go back and use our statistics library only. If you want to print these, so I can write print. I want it to come with the string, f string is there. So statistics for the column that we are choosing. sorry, right? So it will first evaluate this expression call and then it will embed in the string. Okay, so whatever column has been selected from here, that heading will come. So this heading will come, and then we want the mean to be printed. So if we want the mean over here, so it can be, mean should appear in this way. The mean value, we have saved it in mean here. Next we can have the median. Likewise, we can just similarly write it, median, comma, this, print. So if we can recall, so mode we usually prefer for categorical variables, and mode we don't use especially for continuous variables because it does not give much difference, right? So it is difficult to identify the mode there. So we have discussed this in our lecture also. Mode value, and then we just print, we want the cursor to move to the new line. Sorry, so since I have already defined statistics as st, so let me just write st over here and then this error. Yeah, so you can see first it is giving the heading statistics, so it has chosen this column over here, age, and then it is giving the mean of the values from that. Median is 41.0, mode is also coming here, right? Similarly, you will have statistics for time spent. So you see that there is a gap in between this. It is coming just because of this print command over here, because it has shifted the cursor to this. Now once the loop finishes, it prints this and then a space will come, and then again the loop will start. If you want to restrict it to 2 decimal places only, so we can use that same we have used earlier also. We just write f over here and we will just write mean. We will specify the formatting. So let us see if it is giving the correct answer. So now it has considered mean up to 2 decimal places only, right? So this is one way of writing it. If you want, there are other functions as well, right? So here you can use the round off function also, and or the format one also. So if you want, suppose here only I can write, suppose let us do for median now. So median is there. After this you write round, in bracket you will, this median is there, and then whatever number of decimal places you need, you will mention that. Okay, so median, so here it is going to 2 decimal places already, so let us just consider 1 decimal place. So it has given the median up to 1 decimal place now. Okay, so you have calculated the summary measures for the categorical variables, and then for numerical variables we have seen for the measures of central tendency, that is mean, median and mode. So now we are going to look at the measures of variation, that is range, IQR, standard deviation and variance, and also the coefficient of variation for these numerical variables that we have already defined in this column. Okay, so for this we also need one more library, so we will import SciPy library is stats module from there. So I will just write scipy.stats as stats. So basically we have called for this stats module from the scipy library. So basically it allows you to access various statistical functions and methods which are provided by this library, and it has wide range of statistical functions including measures of central tendency, measures of dispersion, in fact hypothesis testing and probability distribution. So you can get all of these here. So we import it first of all, and the data is already with us, and we have already defined the list of numerical columns. So now we can start with the for loop. So we will initiate the for loop. So I will just calculate range, IQR, standard deviation, variance and coefficient of variation. So we will initiate a for loop again as we have done earlier also. Numerical columns, and then we will extract those values from there. Extract data call. So the column that has been selected, all the values will be extracted from that particular column, will be extracted here. Data, first of all we need the date range. So we will call the NumPy library, and from there we will use the P2P function, because it is basically peak to peak, because range is what? Range is max minus minimum, right? So it will calculate the range of values in that particular column. So P2P we write. This is the function from NumPy library, values. After range we need IQR, and for IQR, which is basically the difference between Q1 and Q3, so we need to first find out Q1, Q3. So let me write this Q3, Q1. Again we will call the NumPy library, and we will use the percentile function from there, values, comma, 75, because that is your Q3, and 25 is your Q1, 25%. So it calculates 75th percentile and 25th percentile, that is Q3 and Q1 of the values using the NP percentile function. And now you can calculate the IQR, which is basically the difference between Q3 and Q1. Right? So range is done, IQR is done, then we move on to standard deviation. So I can just write SD over here. SD is what? NP dot, again NumPy library, so it will calculate the standard deviation for those values. Likewise we can have, I can just write small sd. So here we will have the variance, where so I should better write it as the full name, variance np.var values. So this one will calculate the standard deviation for the values, which is a measure of spread of the data, and here it will calculate the variance. So all these four are done, so we are just left with coefficient of variation. So coefficient of variation we need, which is basically sigma by mu, so we need mean also. So let me just find mean also using the mean function from NumPy library, and then we can easily find coefficient of variation, CV I am writing down, which is SD divided by mean. Okay, so it is the ratio of the standard deviation to mean, basically the relative measure of variability in comparison to mean. So first of all we need this heading to come, statistics for column, So you can modify these headings as per your need. This is just an example over here, statistics for this column. And then we need, first of all, we need the range to appear. So range, so we have saved the range in data, comma, data underscore range. So data underscore range we will write. And after range we need the IQR value. So we can write IQR. So what is IQR? We have saved it in small IQR over here. Right. Next is your standard deviation. So we can give the name standard deviation, and what it will give you. Standard deviation, we have used SD. Next you will have variance. Finally, the last one is your coefficient of variation. So maybe I just want it to come as CV only, so I will use this coefficient of variation, and for this I have used the small CV, and I want a line to appear after this. So let me just cross check if everything is, spelling is correct. If statistics for call, range, data range we have used. For IQR we have used small IQR. For standard deviations, SD, variance, and CV. So let me just run it and see what are the values. Yeah, so you can see that first of all it has chosen this age column. The range is 40 and IQR is 20. Standard deviation is this much, variance obviously it's a square of that, and coefficient of variation is 0.29. Right, likewise you have these, but you can see that you can control the number of decimal places also. So I can write F over here, and then range, you can write the range, specify the formatting for this up to 2 decimal places, close this curly bracket, and then put this F range, data range, so you can see the range has now been written only up to 2 decimal places. So same thing, you can see IQR, I suppose we can write for all of these, right? So let me just change it for, let us do it for just variance, and likewise you can do for others also. So here you will remove this and you will write this one as quote. Here you will specify the formatting, which is up to 2 decimal places, close this curly bracket, and then close this quote. Okay, so you can see that variance has also been now written up to 2 decimal places. So likewise you can do for others. Okay, so we are done with the different summary measures. For measures of skewness, we will see it in the next week, because there it will be more evident when we draw histograms, and from there we will be able to identify skewness. Okay, so now we will be moving on to the Chebyshev's theorem. Theorem basically provides bounds on the proportion of the data that falls within a certain number of standard deviations from the mean. So for this we need to import one more Python library, that is matplotlib, and from there we want pyplot. So we are importing the module pyplot from the matplotlib library. which is basically a comprehensive library for creating different visualizations in Python. And it is a very convenient and simple interface for creating different types of plots and charts. So we will be using it over here. So import matplotlib.pyplot, which is a module from that, as PLT. So we will first define the number of standard deviation. So let me write as k values. So we use the notation k usually. So we call the NumPy library. Is this basically we are calling the NumPy library and trying to generate an array of values for the number of standard deviations. So it will start from 1 and it will exclude the 6. So it will go up till 5 only. So it will contain the values from 1 to 5. So you can change the range. So I have taken over here 1 to this range, but you can change it according to your need. So now we will define the corresponding proportions. So proportions, I'll just write prop over here, which is nothing but 1 minus 1 by k square. K values, and you know that if I have to write power, so I will use double asterisk over here. So this step is going to calculate the corresponding proportions within the specified number of standard deviations using the Chebyshev's theorem formula. That is 1 minus 1 by k square. Okay. Now we will create a plot. So let me give the command for that. lt.figure. We will give this argument fixed size to determine the dimensions of the figure. Fixed size is basically 8,6, which means here it is, the width is 8 inches and height is 6 inches. So this will create a new figure for the plot with the specified figure size of this. Okay. Plot.figure. So we want to call the plot function over here. So k values will come in the x-axis and prop we want in the y-axis. Next we want a marker as 0 over there. So it will specify that circular markers will be used to denote the data points. You can use something else also. We will see that later. So marker is 0 and the line style we want, suppose you want the line style to be a solid line. So you just write this. Further you want the color to be blue and the marker size to be 8, right? So what it is doing, it will create a line plot using this plot function. So k values will be on the x-axis, proportions will be on the y-axis, and wherever you have the data points, it will mark this over there and line. So you will have a solid line for this in blue color, and the size of these marks will be 8. You can vary it according to your need. Now we want the label for x-axis and y-axis. So plt.xlabel. So that will be number of standard deviations to appear in the x-axis, number of standard deviations. k, we want this to appear in the x-axis, and on the y-axis we want the label to be proportion within k standard deviations. And the title for the plot, I can name it as since a single quote is already in Chevyshev's, that is why we will be using double quote over here. And then finally we will write that we need the grid to be true over here, because it will make it easier to read and interpret the data. So grid, we will write true, and then we will show the plot over there. So let me just, whatever we have generated, let us see what it is. Plot dot show. Yes, so you can see that here on the x-axis you have the number of standard deviations that we have given the name, and here on the y-axis you have proportion within k standard deviations, and the overall title is Chevyshev's theorem visualization. X-axis you can see the k values are there, which goes from 1 to 6 we have written, right? So here you can see it is varying from 1 to 6 or 1 to 5 it is there, because it will not include 6th one. And on this side you have the proportion, so that is why it is going from 0 to 1 only. Markers is 0, so you can see these are the data points that has come out, so it has marked these O over here. So I can change it to asterisk also, right? So suppose I change this, how will it change? You can see the figure now, right? Similarly, I have used a solid line. If I want a dashed line to appear, I can use this and it will change. I can likewise change the color of this plot also. So from B I have used for blue, I can use R, so it will give me a red color, and I can change the marker size, so it will appear in this way. And the grids, you can see that since it is true, that is why it is giving me grids. Otherwise, if I can give the command false, so you see that the grid lines go away. However, if the grid lines are there, it makes it easier to read and interpret the data. So as of now, we will keep it, and I will explain you what does this mean. Now what it is saying is that if you now choose k as 2, right? Now k is 2, and if you see the data point corresponding to it, then you see that the proportion of data points that fall within this is in fact your 75%, right? It falls within 2 standard deviations from the mean. So at least 75% of the data falls within this range. And since Chevyshev's theorem does not assume any specific shape of the distribution, and it is just providing a general rule that is true for all data sets, so you can use the plot to understand how the proportion of data within a certain range changes as you increase the number of standard deviation. So I can change this 6. Suppose I now make this change till 10. If let us see what happens. So you see that how the shape now looks like. Okay, so this is how you can visualize. So for different values of k, you can look at k at 3. You can see what is the value over here. It comes out to be around 88% something, right? And likewise. So now we are going to see and compare the z-scores. So if you can recall, how do we calculate a z-score? Z-score is basically x minus mu by sigma. So x is the data point, mu is the mean of that data set, and sigma is basically the standard deviations. So it measures how many standard deviations a particular value is away from the mean. So it can be positive also and a negative value also. So let us see. So here let us suppose that we have two users with name Raj and Mary, and you want to compare their z-scores for the time they spent on the OTT platform. So based on your data set. So first of all, we are going to extract. So let me just write the comment over here. Compare the z-scores of Raj and Mary. Okay. So first of all, to do this, we will extract, since we are talking about the time spent, right? So we have to extract the time spent column from the original data frame that was their data, right? So we will first extract the time spent column. So let me just write time spent column, and so this was the original name in the data frame, and here we will add this dot values. So here what it is doing by mentioning this, it is basically converting the column data that was in this time spent. It has converted it into a NumPy array. Okay, and then it can be easily used for your mathematical calculations. Okay, so we have first extracted this time spent column from the original data frame, that is data, and now we are trying to convert it into an array. Okay, so this variable over here, that is time spent column, that it stores the values of the time spent column from the pandas data frame data. Okay, so now we move on to, because we have extracted this time, now we want to calculate the mean and standard deviation for this data, because for calculating the z-score we need mu and sigma. So we will calculate the mean and SD. So you can write mean time as NP. So we will call the NumPy library and with the mean function as we have seen earlier also. So I will just write this time spent data, and similarly SD can be SD underscore time. So again you will call the NumPy library, and here you will use the std function and time spent underscore data. Mean we have got and SD. Okay, so there is time spent, not it is not data, it is column, sorry, time spent column, and here you will have time spent column. Okay, so maybe if you want to see what is the mean time, so let me just run this. It is around 5.005, and let us see what is standard deviation of that. It is 2.85. Okay, so now suppose from the data set you have the time that Raj and Mary spent on these platforms, so that is given. So you can see, right, because here time spent column is there. So if you want to see from here, so let me just write, maybe we can write here also. So time spent column, so how does it look like? Let us just see. Okay, so this is now in the form of an array, and these are the values. So you can see it ranges from 5.1, 9.1 is also there, right, 6.0, and it is as low as you can see somewhere 0.5 is also there, right? So in this data you will have the time that Raj and Mary spent on this platform, that is also with us. So now let us consider that Raj spent, let me just write it, Raj spent, suppose I can consider it as 6.6, so he spent 6.6 hours on the OTT platform, whereas for Mary, I will write Mary spent. So let us see one of these values. So we can consider here 0.4 is also there, or we can take 2.3 from here. So 2.3. So this is the time that Raj and Mary spent on the OTT platform. Now we want to calculate their corresponding z-scores. So let us write that z-score for Raj. So we know that the formula is x minus mu by sigma. So x is Raj spent minus what is mu, mean time, mean underscore time, and this whole is divided by sigma, that is SD underscore time, and the other one is z score Mary. This is the time for Mary, so you will just write Mary spent minus mean time divided by SD time. Okay, so now we have written the formula for calculating the z-scores of Raj and Mary. So you just write compare the z-scores. So, and this command for that is, we will use a if else statement. If z-score Raj is greater than z-score Mary, then you will say that we'll just higher relative score will give me the output Raj. Else, if just copy it from here, if z-score Raj is less than that of Mary, so it will give the output Mary. And if any of these conditions do not hold true, then finally we will have the else statement, which is higher relative score is that Raj and Mary have equal z-scores. Now let me just mention underscore over here. So what is now happening over here is that you are comparing the z-scores of Raj and Mary. So if Raj has a higher z-score, it means that he spent more time on OTT relative to other users. Otherwise, if Mary has a higher z-score, you will say that she has spent more time on the OTT platform. And the third case can be when both have spent equal time, right? So let us see the output. Now let us display the results. So we will print. So we can also print the mean time. Mean time spent on OTT. So that will be given by mean underscore time. The other one can be the standard deviation likewise. So we can print the standard deviation of time spent on OTT. Mean time. So this will be SD underscore time. Next one will be your print. So we want the z-scores also. So it will give me z-score of Raj for the time he has spent on OTT. So that is represented by Z underscore score underscore Raj. Similarly, you can have the Z score of Mary also. So we'll just change the name over here. And last, we will print that who has a higher relative score. So you will use the F string here. The person with the higher relative score in time spent on OTT is higher relative score okay. So this is what you have. So mean time we have seen it's approximately 5 hours. Standard deviation is around 3 hours. So Z score, if you see, it is 0.558. So it means that, and it is a positive Z score. So it indicates that this value is above the mean. And in fact, it is 0.55 standard deviations above the mean. Okay. And for Mary, if you see, it is coming out as negative. So Z score over here is negative, which means that it is these many standard deviations below the mean. So it is 0.94 standard deviations below the mean. And in the end, what you get, the answer is that the person who has a higher relative score in time spent on OTT is Raj. So in comparison to Mary, Raj has higher Z score. Okay. So we have seen the summary measures for categorical data set, that is count, mode and proportion. Then we move on to the numerical variables, and we saw the measures of central tendency, that is mean, median, mode. We also saw the measures of variation, that is range, IQR, standard deviation, variance and coefficient of variation. After that, we saw and visualized the Chebyshev's theorem. And finally, we compared the Z scores of two users in terms of the time they have spent on the OTT platform. Thank you.